Hi there, this is Aramila from AM Science Extra. In this lesson, we're going to look at electric current, and this is our part one under electricity. So, when we're looking at electric current, there is firstly a need for us to be able to understand what we call circuit symbols. These are simply symbols that we can be able to use to represent a particular electrical component in a circuit diagram. For example, you're given, let's say, draw a circuit diagram which has a battery, which has two cells, or which has maybe two bulbs, which has three resistors. How can you be able to know to say, okay, a resistor should be able to come out like this? How can you know that a lamp or a bulb should be able to come out like this? So it is important for us to be able to know the circuit symbols that can be used when it comes to drawing what we call circuit diagrams. So the first one that we have is a switch. So a switch may be open or closed. So the first one that which we have is an open switch. That simply means that it is not yet turned on. And then we have a closed switch. That one, it means now that something has been turned on. If it is a bulb, it is going to be lit. And then we have a cell. So a cell is simply made of the positive and the negative. The longer line there, that is the positive, and the shorter one is the negative. So for a cell, it will just be able to have two lines, one tall and one short line. That is the cell. Now, when we bring two or more cells together, what we're going to have is a battery. That is why it is something that is very wrong to say kashite battery so that is something that is wrong. A battery can only be made of two or more cells. Just a cell, it will be called a cell. When it is just one, it is called a cell. Two or more, that is a battery. And then we have a diode there, we have a resistor, we have variable resistor, we have LED, that is a light emitting diode. And then there is lamp there is fuse, there is voltmeter, there is ammeter, there is thermostat, and then there is a light dependent resistor. So those are some of the circuit symbols that we need to know. It is important that we know those circuit symbols as they can be able to come to help us be able to come up with a very simple circuit diagram. It is important for us to understand that. So now we can be able to have a look at electric current. So when we're looking at electric current, we're told that it is simply the rate at which charges flow. And these charges that we're talking about are electrons. So when we say rate at which charges flow, it's basically it is just the speed. So when it comes to coming up with the formula that we can be able to use when it comes to this, we can be able to say current is equal to charge, which is in coulomb, divided by time, which is in seconds. That is the simple formula that we can be able to use to calculate the current. And then there is also a need for us to be able to know the symbol for electric current, which is just capital letter I. When you're writing an equation, in many cases, we use symbols. So it is important for us to be able to know that the symbol for current is capital letter I. And then we also have the unit for electric current, which is the ampere, written as capital letter A. So there is just one thing that we need to take note of here, which is the using of capital letters. When you're writing the unit in full and it is named after a person, you start with a small letter, just like I have done. When it comes to writing the symbol, you use a capital letter. We have, for example, Pascal. When you're writing it in full, you start with a small letter P. And then when you're writing symbol, you start with a capital letter P and then A. When we look at Newton, you start with small letter N, symbol capital letter N. It is important for us to understand that. And then there is also a need for us to be able to know the instrument that we can be able to use to measure electric current. And this instrument is the ammeter. And now there is a need for us to be able to know how we can be able to connect an ammeter in a circuit. So now, before we look at the series and parallel connection of these instruments, there is a need for us to be able to know when it comes to the terminals. So just like a battery has the negative and the positive, even the ammeter has the negative and the positive. So it is also important for us to be able to know which one is the positive and which one is the negative. So when it comes to connecting an ammeter in a circuit, uh, we need to connect the negative terminal of the battery to the negative terminal of the ammeter, the positive terminal of the battery to the positive terminal of the ammeter. That is how you connect that. And then now, how does this connection happen? We are told that an ammeter is always connected. Mark that word, always. An ammeter is always connected in series to an electrical component whose current you want to measure. It is important that we understand that point. We are saying that an ammeter is always connected in series. When we say in series, it's more like just in the same wire with an electrical component. There is no junction at any point. So it will just be in one wire, just like we're able to see. The ammeter and the load there, which may be a resistor, which may be a bulb, which may be a refrigerator, which may be any electrical component, they are just in the same wire. There is no junction at any point. So that kind of connection where the ammeter is connected in the same wire with an electrical component as well as the battery, we call that series connection. So we need to know that an ammeter is always connected in series to the electrical component whose current you want to measure. As simple as that. And basically, that is what we need to know concerning electric current. So always we are here, as we all know, we are here to give you science, and therefore there is a need for you to be able to subscribe to AM Science Extra to watch exciting part 2 of electricity, as well as to watch some more exciting, easy to understand science lessons. Thank you very much for watching.